Hello, and welcome to our video review for our first test here in 251. A few thoughts, a few comments as we get going. So first off, I'm going to be assuming that you have the PDF of the problems accessible right now. I'm not going to be handwriting out the entire problem, so I'm assuming you have access to that. Second thing is that you are strongly recommended to watch these videos after you've tried the problems, after you wrestle with them yourselves a bit. So you may want to, stop watching this video right now and try some problems. Throughout, you're always encouraged to try the problems before, pause for a little bit, try the problems before watching the video. Okay, so without further ado, let's go ahead and get started. So problem number one, U and V are two vectors. I'm telling you the lengths of U and V, and I'm telling you the length of U plus V, and you need to find the angle between U and V. Okay, so what's going on here? So the length of U is 3, the length of V is 4, the length of U plus V is square root 13. How do we get to the angle between them? And of course, we know that cosine of theta is U dot V over the magnitude of U times the magnitude of V. So really what this is going after, we know the magnitudes of U and V, we need a dot product. Here's the trick. Let us look at U plus V dot product with U plus V. So we distribute out the dot product here, and we know that U dot V is equal to V dot U. We end up with U dot U plus 2 U dot V plus V dot V. Okay, what do we know about this? Well, U dot U is the magnitude of U squared. So this is 3 squared. V dot V is the magnitude of V squared. So that's 4 squared. So this expression here is 3 squared plus 2uv, U dot V, plus 4 squared is 25 plus 2 U dot V. Well, on the other hand, the absolute value of U plus V, the length of U plus V, well, we know that the length of U plus V squared can be computed by just doing U plus V dot product U plus V. And so this is the square root of 13 squared is equal to this. That's 13. But U plus V dot U plus V is exactly the expression we started with right here. So this is equal to 13. So at this point, what do we see here? 25 plus 2 U dot V is equal to 13. If we simplify this, solve this for U dot V, 2 U dot V is equal to 13 minus 25 is negative 12. U dot V is equal to negative 6. So what are we left with? Cosine of theta is U dot V is negative 6 over the magnitude of U is 3 times the magnitude of V is 4. Cosine theta is negative 6 over 12, negative 1/2. And this is one value that we should know off the top of our heads. What is theta going to be here? If cosine theta is negative 1/2, theta is 2 pi over 3. Okay, so what's the point of this problem? The point of this problem is realizing these kind of tricks here, that U dot U is the magnitude of U squared, V dot V is the magnitude of V squared, U plus V dot U plus V is the magnitude of U plus V quantity squared. And so realizing that, that it doesn't look like this information in here gives you It doesn't look like this is giving you information here about u dot v, but it actually does give you information about u dot v. Okay, that was problem number 1. Problem number 2, we have a initial value problem here. So we're told that r prime of t is 3/2 t to the 1/2. Sorry, t plus 1 to the 1/2 I hat plus 2e to the negative t j hat plus 1 over t plus 1 k hat. So to go from this to r of t, we just need to integrate each of the terms separately. So r of t is going to be, what's the antiderivative of t plus 1 to the 1/2? That is going to be, that's just going to be t plus 1 to the 3/2 I hat, because there will be we'll divide by 3/2, multiply by 2/3, and that will cancel that out. The antiderivative of 2e to the negative t is negative 2e to the negative t j hat. And then the antiderivative of 1 over t plus 1 is going to be natural log absolute value of t plus 1 times k hat. And then we want generic antiderivative, so we need to tack on like c1 I hat plus c2 j hat plus c3 k hat. This is our generic antiderivative for our original function. What haven't we used yet? We haven't used our initial condition that r of 0 is equal to just k hat. So what does this tell us? When we plug in 0 here, let me just take this entire expression and plug in 0. So you're going to get 0 plus 1 to the 3/2 is just 1 I hat minus 2 times e to the negative 0. E to the 0 is 1. Negative 2 j hat plus natural log of 0 plus 1 plus natural log of 1 is 0. So plus 0 k hat plus c1 I hat plus c2 j hat plus c3 k hat. Okay, so we want this to equal k hat. The coefficient of I hat needs to be 1. 1 plus c1. So that shows us c1 needs to equal negative 1. The coefficient of j hat needs to be 0. Yeah, the coefficient of I hat needs to be 0, so that we get c1 is equal to negative 1. Coefficient of j hat needs to be 0. Negative 2 plus c2 is equal to 0. c2 is equal to 2. And then the coefficient of k hat needs to be 1. So c3 needs to equal 1. So our final answer here, r of t, is t plus 1 to the 3/2 plus c1 I hat. Minus 1. I need to actually plop in what c1 is there. Plus negative 2e to the t plus 2 j hat plus natural log of absolute value t plus 1 plus 1 times k hat. So really, when we're solving this initial value problem, this is really just nothing more than solving 3 separate initial value problems in a Calc 1, Calc 2 way. So, if I say to you the derivative of your function is 3/2 t plus 1 to the 1/2, and with initial condition of 0, you end up with this. We're just doing this component by component.